So let's get started. Let's see what we have today. So the main goal of today is to cover ANOVA, which will be exams, part of the exam. So so some of you asked me the scope of exam. So I decided that I would not do regression. Regression will be out of the scope. And for ANOVA, I will just do one-way ANOVA as a scope. So basically, the exam scope will be up to today's class. Okay. And I'll clearly write down what it is, but mainly speaking will be 1 up to 7. And for hypothesis testing, because many of you have said the 2 sample is too complicated. The formulas after the 2 sample one is very complicated, which I agree. And since you are actually using a formula, right, and anyway in the calculation, so I would just in the exam I would just ask you how to handle the Excel for a 2 sample and ANOVA. So you need to know how to use Excel, which function to be used, and also how to read the Excel output for the 2 sample one and the ANOVA. Okay. Otherwise, but before that, you need to know how to do calculation by hand, by other stuff. Okay. So that would be I would put the announcement later. You will be seeing the scope. Okay. But I think that would be available later. Okay. But another thing is for the exam, I just take away 1 question. So instead of 4, we have 3. So only 3 big questions, right? The format is very similar to the previous past paper, right? We have 4 questions, but now we have 3 questions. Okay. And no multiple choice. Bring as many as you wish. Okay. I hope that will be okay. We'll go through the sample paper the very last class. So next Friday we'll go over the past papers and also Q&A. Okay. And of course, if you have any question, you can tell me in the room reply later today. Okay. Today the goal is not very ambitious. We will cover ANOVA. Okay. One way ANOVA, and mainly focus on Excel calculation. And the regression will be focused on calculation as well. So although regression is not in your exam, I still expect you pay some attention. If I can't finish everything, I will cover things in the makeup class. Will be on the which of the exam, right, where I do in the B.B.A lab there. But that one is optional. But anyway, I don't feel too bad if I don't cover fully for regression, because for those who actually want to go further, we'll do 2021, which in the whole semester you study regression only. So it doesn't hurt me that much. But I think I need to give you a more detail on the ANOVA. Okay. So just to go back, what is ANOVA? I want to use a graph to illustrate the idea, right? The main idea of 2 sample t-tests, right? Remember, is I have population 1, right? Maybe this is a group of males, right? How much they want to spend on the product, follow a bell curve, right? With mean mu 1, right? And sigma square 1 here. And a group of women, okay? Population 2, right? Which are scanned coming from mean mu 2 and sigma 2 square, okay? And we focus the question last time we studied this problem, right? The 2 sample case, not equal to, right? And in the particular case will cost us on sigma 1 square equal to sigma 2 square equal to sigma square, right? The same shape, right? And we can compare it using hypothesis testing. This is called the t-test, right? T-test with the same variance. So ANOVA is trying to generalize this test to more than one group. Okay, I not only want to compare boys and girls. What happens if I want to compare locations? Location, right? Maybe this is Hong Kong, this is Kowloon Peninsula, right? But I also want to compare new territories, maybe Macau, Shenzhen as well, right? If you're in the Greater Bay Area, right? So that is more than one group. You want to see different group have different, say, profit or different sales or different whatever, and to make business decision, right? So that's the idea, okay? More than one group. Are they different or not, right? And suppose you're a financial analyst, right? You want to compare the, say, the new shop they open, is it going to be as profitable as the old shops, right? So that would be the question. Or you have a new designed product, are they going to sell the same way or the old way, right? So that would be the question we're asking. So I hope it's clear what we're asking. It's a generalized t-test with equal variance, okay? So now let's motivate that. And do note that although there are a lot of formula here, our goal is to tell you what are they and then focus on Excel output. That is what I'm asking in the last previous test. You expect me to ask because that was the key point of ANOVA. Okay, and although ANOVA is not frequently used, but the concept or idea that extend in general to regression or other thing. Okay, so basically that is the starting point of you starting to do studies, more serious study of statistics, right? So now we are going to talk about ANOVA. Okay, so the model is very simple. Now we extend our data, not just an observation, but also its grouping. Okay, we will not only observe a guy, how much he make or how much he spend on your shop, but also observe his gender, age group or country where they come from. So these are the problem. We focus on only one grouping. Okay, so data you have is, for example, if you collect data in CHK, right, you will know in our school you collect, say, how much he spent on his lunch, which is X, right? And we ask which college you are in. Okay, NA, UC, CC, so forth and so forth, right? So X1, G1 will be the observation for the money he's spending on the lunch and which college he's in, right? Or if you want to care about the GPA, right? The GPA or the observation guide number 1 and NA, right? So on and so forth, right? Turn out there will be C number of group. Say in terms of colleges, you have 9 different colleges, right? If you care about the district in Hong Kong, we have 18 districts, right? So on and so forth, right? So these are the data, and this is how you put the data together, right? This is how you usually collect, right? And you collect them by row. Usually they call the long data, right? This one is you ask the first guy how much he's spending in your shop and whether it's which group they're in, right? Maybe each shop they're spending, right? Maybe shop number 1, right? He spent $1,000, right? And this guy may be spending $300 in the shop number 2, and there's another guy maybe spend on number 1 as well, 2K, right? So on and so forth, right? You collect the data, how much he spent in your shop, and which shop he spent their money on, right? So that would be the data, right? Each data will be associated with the grouping we care, okay? So that is the question. That is the data set we have, okay? So the underlying goal, sorry, I should not erase that, is it you want to distinguish, say, each different shop would have different mean, right? That's a question, okay? Same as what we said, right? Because it's same as two sample t-test, right? 2 sample t-test asking whether the group mean between group 1 and group the same, right? So we generalize this problem, okay? And in order to study this, we have to introduce a very complicated notation. Okay. Is the following. We will denote all the data sorted by group. So every data will be X, I, J, okay, 2 subscript. The first subscript tells us which group he is in, 1 up to C, right? I is 1 to C, right? And J, okay, is the order of observation in each group, right? So it goes from 1 up to NI. NI is how many observation in group I, right? So sum of all is N, okay? So this one still looks a little bit terrible, but let us look at the way actually we store in the Excel, or the data form is called the matrix form. This is the form that Excel will take your data in, okay? So if you ever do analysis, this is the form that we expect to see, okay? So let's see this example using our ID of CHK, right? So group 1, maybe NA, right? Group 2, maybe UC, and so on and so forth, right? Maybe so, right? And X11, right, will be the first NA guy. We ask, say, how much GPA he has, right? Maybe this is 4, right? And this guy maybe 3.8, okay? And this guy maybe just 3, and so on and so forth, right? So we just have N1 will be not total number of people from NA, right? So it's collected, the same group will be collected in terms of the column, okay? In this setup, right, order of data doesn't matter, but whether it's in which column it matters, right? In which row doesn't really matter, but in which column is different, right? Which column will tell you which group they're in, right? The order of, you can swap any order in the column, no change to the data set. But if swap across group, across column, it's not correct. You cannot do that, okay? So that will be the data we have. It's called the matrix form. And this is the form, as I emphasize, this is the form that we will do our analysis using Excel, okay? So you have to collect them, right? Because you have to convert the data we collect in the long form, right, to this form, okay? I think you can use some Excel function to do that, but anyway, this is the form we have, okay? Now, once we have that, then the idea is try to see, right? We want to see if the mean of here, right? If you calculate this mean, we call X bar 1, right? This, which means the average of NA, right? And this might be the average of UC, and so on and so forth, right? And the question would be, we're asking whether each group actually a different mean, right? Is it people from the NA or UC has NA, maybe they study harder, right? Or people in the Saw College is study less hard because they have much bigger space, have more fun. That was a rumor when I was a student, but probably it's not true, no longer true anymore, but that was the case, right? And you try to look for evidence, right? And if the sample mean are similar, then probably you don't find that it's convincing, right? To say they're different, right? If the sample means are somewhat different, then you want to do a test, right? Onward, because you want to see if these mean are different or not, right? So the sample mean tells you some idea, right? So that would be, but we will not use the sample mean to take a difference. If there's only 2 groups, right? You can just take a difference, do a t-test, right? That is what you have done, right? We then just do a t-test, right? And t-test, we can do it now, right? You know how to do that. We talked about that last time, right? Just t-dot test and just 2 columns and we're done, right? But the question is, we have many columns, right? Then how can we do it once and for all, right? Or we should do a first round test, right? We want to do a one test, let's see if they're different or not, then before we do one by one, right? We can do one by one still, but the first thing is, if we have many columns, right? Then we want to see if actually they're different or not first, right? So that's a question. Okay. So let us go into detail of the model. Okay. So this is probably the first mathematical model that you learn. Okay. We start to put what we learned from, probably we also learned it in last class as well, but this is the more formal model, with more interesting model, right? Is that we assume, we start to make some assumption, the observation we observe, right, actually follow a bell curve. Okay. So this is the model we are looking at, right? So basically what you are saying is, okay, maybe NA people, okay, follow a bell curve here, okay, mu NA, right? And people from CC follow this, okay? Everything follow bell curve, and the shape is the same, okay? The shape is the same because the sigma is the same thing, okay? Just the difference between group only come from the location of the mean, okay? So that is the first model we are looking, okay? So do note that when we talk about model, which means the assumption, we hold, okay? We just assume, okay, the GPA or the income or whatever thing you want to observe, or the money they spend on the lunch, okay? Actually the same shape, only different location, okay? This is the model. So of course, this model is very simple. Later when we learn regression, we talk about today, we have a more complicated model. But what it means is we are assuming there's some mathematical structure, right? There's a bell there, and we are trying to use this structure to understand the data, right? To see what we understand is whether the NA and UC, maybe add one more because we want free group, right? To be more fun, right? Maybe this is mu of UC, right? And we want to ask the question, sorry, same shape. We want to ask the question, is these three are actually the same or not the same? Okay. We want to test if the same or not. Okay. I mean, they're all the students from CHK, right? We want to see if actually the college make a difference. Okay. Maybe no difference when they join the first year, right? But after 4 years later, that may be, right? So that might be the question that we want to ask, right? Is the question, right? The school want to know, right? Is any college experience after 4 years make you different, right? Is it people go to CC become more Catholic after 4 years, right? Or people go to NA become more Chinese oriented, right? Learning from the New Asia College, right? And maybe people go to Shaw College like to watch TVBs, so on and so forth, right? So these are all the questions that we're interested in asking, okay? So just to remind you what we're asking is this three mean the same or not? Okay. Now, because when we write this as a three bells, indeed we can express our model in this formula. Okay, it's the bell. This is the very classical way to write a model in terms of equation. Okay, we'll write. Well, this is random variable, consists of two parts. One part is a number which is there's no probability, okay? It's unknown, but it's not probability. Unknown, okay? But not probabilistic, but not random variable. Okay? And this guy is a random variable. Okay? And of course, this is sometimes we call deterministic. Okay? And we distinguish, usually write down something don't know is divided in two parts, right? Why we do that? Because we can estimate this part, right? This part you cannot estimate, but this mu is we can estimate, right? but that's easy. How can we estimate mu I? Say, what is the mean? What is the population mean for NA? It's very simple. We can use the sample mean of NA to estimate that, right? So to estimate this, we can just simply use X bar I, right? So if you want to guess what is mu I, we can just X bar I, right? So that's how we guess it, okay? And if we want to guess this one, there are many ways to do it, right? You can use S square I, right, to estimate that, right? But because the shape is the same, right, we can also use Sij, which is not the group, right? There are many, all the other group also as well, right? But you can come up with a better way to estimate that, right? The best way is to ignore the grouping, right? You forget the group and do some calculation, which later you will see. This is called the later you will see. Okay, later I will show you. It's called later you will see how to measure that, but I don't want to. But actually the key is this is constant. We will utilize the same for every group. That would be the key to do the F test. Okay, but very soon we'll talk about that. But don't worry, this is the part that will be the key of the model. Okay, so now the question we have is we define two things, which is overall mean, okay, which is mean of the group's mean, okay, and the difference between each group mean minus the overall mean is called the treatment effect. Okay, that's the definition. So graphically, what it means is like this. So I have data, right? X1, right? This one, right? You take three number, this average of three number, right? It's mu1 plus mu2 plus mu3 over 3, right? That's the middle, okay? And you are trying to say what you observe the bell is the red one, right? Instead of the red thing, you decompose it into this mu and epsilon, right? If I epsilon 1, I plus mu become x1, okay? So I no longer care about x1, right? That is, I decompose it into two parts, right? So the same as the blue thing will be the mu2 plus the epsilon 3, so on and so forth, right? So, and the distance between the sample, the group mean and the grand mean will be called alpha 1, okay? And alpha 1 can be positive, negative, depending on the left-hand side, right-hand side, right? So this is negative, right? This is negative, this is positive, okay? And if we are saying that mu1, mu2, mu3 are actually the same, it's asking alphas are 0, okay? So that is actually I write in the next slide here, okay? Later we'll see, okay? But before we do that, we have this model, right? The model we're doing is mu1, mu2, mu3, right? And sigma square, okay? So just to remind you, ANOVA, right? The parameter of the model, ANOVA model, we have mu1, mu2, mu3 up to mu c, right? And sigma square, okay? So these are the things that govern the model, right? As long as I give you all this number, we know exactly what the real world is, right? Our real world is governed by, you think, or we think, we assume that it's given by all this number, right? The only thing we want to see is this number the same? It's the ANOVA idea, right? This is our setup, okay? Of course, the first thing is to come up with a guess for mu, right? And the next one is come up the guess for the sigma, right? So that is the thing. So how to estimate mu? Okay, is by, as we said, using the ground mean or group mean, right? The ground mean will be just very simple, just add up every number and divide by n. Okay, so look at this notation, looks crazy, but let's do one by one. This means you are adding the group from group 1 to group C, right? Because Xij, this is which group you are in, right? Which group? Okay, and J is which observation in the group. Right? So basically asking, you go over every group, okay? And for each group, you go from observation 1 to the end of the observation until by n, okay? So this is still looks not graphical, but let's look at this. Basically, what it means is you just add up everything divided by n. N is total number of them, right? So basically, simply what? The mean without the grouping, right? You forget about the group, just the mean, right? So that is the grand mean, right? So grand mean is what? It just, right? You just calculate mean without group, okay? And sample mean for group I is just mean within group I. What does that mean? It means that I just focus on group I, okay? Just focus on one column in data. I forget everything about it, right? And calculate the sample mean, okay? Then graphically, what does that mean, right? Graphically, the table, it simply means, as I already said, this one will be x1 bar. I look at this column, I calculate the mean of that, x bar 2, okay? So this is the sample group mean, okay? I hope that is clear. Now, what left is, okay, we know how to estimate the data, mu1, mu2, and mu3, okay? So what is left is the sigma square, right? The model. This is the model we're asking to estimate, okay? And let's take the example, right? If there's a, these are data, right? The overall mean will be just adding all the number divided by how many of them. One is just adding this 4 up divided by 4, so on and so forth, okay? Not going to bother you with this example, okay? And the question is, once now we know how to estimate x1 bar up to xn bar. The question is asking, can we from this estimate this, are they the same, right? So that's the question. And or is the treatment effect is 0, okay? And I have already emphasized why we want to care about that, right? Because suppose an experiment, the medical one, right? You have the many combination of treatment. You want to do is any treatment would lead to different effect, right? If they're different, then you can try to pinpoint which one is better and do second stage, right? But of course, you may ask, why I can't do t-test one by one, right? But you can do that, but f-test is much faster. If you have many groups, right? Better to do an f-test rather than t-test, right? So you say f-test is a quick way to do many t-tests at the same time, right? So I think the example is clear enough, but okay. So how do we do that? As I said, the key thing to do it is because every group have the same variance shape, sigma. So we come up with different way to estimate sigma, okay? And then turn out that we will see if under this, okay, there's a one way to estimate sigma square, okay? And if doesn't hold, that's another way to estimate sigma square, okay? And we try to compare two variants, okay? So let me maybe be very clear. Okay, so what is it about is we want to calculate variance, right? So let's focus on the numerator part first, right? Numerator is something square, right? Remember the variance, right? We just subtract the mean and square that, okay? So the first one would be the variance numerator if you forget about grouping, right? If you forget about grouping, what you do is take each observation minus the overall mean, right? You add that from each group, right? And from each group, you start from the first observation to the last observation, right? So this is sum of squared total, SST, is the one, if you forget about grouping, you try to calculate variance, this is the numerator, right? Take every observation minus the overall mean and square, okay? Right, so you will see later, this is our, right, estimate of sigma squared. That's one way to estimate that, okay? If we really forget about grouping, right? This is what we do, right? Nothing special. Just look at all observation, right? Find the mean, take a difference between the mean and that and square, sum of that. Okay. And now the next one is slightly a little bit tricky, but this summation the same, right? Just basically go over all the observation. The only difference is what we are subtracting, okay? The second one we call SSG is called between group, okay? Between group is what? You will see I still subtract overall mean. But instead I look at every observation, I just replace by its group mean. What I'm doing? I am doing is erasing the variation within a group, okay? So what I'm doing is look at the data back. Look at the data, okay? Data is here, okay? So instead of using each observation, I calculate its mean. I put back all the mean there, okay? I do it for each group, okay? Every group, all the observation replaced by its group mean. Why? Because when I do that, within the group, there's no variation, right? Every observation is the same, okay? And if I calculate variance of this whole thing, okay, then actually what I got is the difference between group, okay? So that's why we call it between group sum of square, SSG, is between the groups, okay? I think some of the book will say SSB, so it depends on the book you are reading. They will sum of SSB, okay? And next is called the next one, okay, is the other way around. Is I don't change the first guy, the same thing here. I only change the last guy, okay? I'll change the last guy. I subtract not the grand mean, but the group mean. Why I do that? Is I look at variation within the group, right? Because I'm looking at each time I look at all the observation, I minus what the group average is, okay? And turn out that the overall variance, okay, can be sum of the two, okay? So this is the formula, very important, but I'm not going to prove it, but that would be, the thing is, you can decompose the variance, total variance, into two parts. One is total variation come from between group. The other is within group, okay? So probably you would think, why it's true, right? Besides, you can go to the math, but I want to argue graphically this is right. Let's see the graph. Okay, the graph like this. Look at the data here, okay? This is the grand mean, right? Sample grand mean. Okay. And I look at particular observation here, okay? when I calculate SST, right, I look at how this different from that and square, right? I do it for every observation, right? Because I forget about the grouping, right? I look at what the value is, look at overall mean, distance, square, add them up. It's SST, right? But I can do it in two separate steps. I can look at how this go to its own group mean, right? And then I look at how this group mean, this is called SSW, right? Within group. Okay. But I can also look at from within group to this is called across group, right? Okay. SSW, SSG. So that's why the total variance can be decomposed in two parts, SSW and SSG. Okay. So that is the graphical explanation, right? You go from your observation to the grand mean. You can do it two steps. You can go to its group mean first, okay? And how the group mean go to the grand mean, right? So that's why you can decompose it into two parts, okay? Now, once we're done with that, then we remember, actually we are trying to look at the variance, okay? But to do the variance, we'll divide something, right? But what is actually we're talking about the variance here, okay? The idea is very simple, okay? The variance come from this, okay? If mu1 equal to mu2 equal to mu3, say, if this is true, the variance calculated from that one should be very similar to this guy, right? Because they're same location. So the variation, you can prove they're the same thing, the idea, right? You can imagine if actually they're very far away, this guy will be very large, right? But this is still within this, right? You can imagine this x2, x3 is here, right? So this thing will be very big, right? So we want to, so the ANOVA is just an F test. Try to compare variance from this one to this one. So it's a one-tail F test. Okay, let me repeat. If actually the group have very different group mean, right? The bell are very separate. The variance calculate between the group mean and grand mean, this guy, will be much larger than each observation within the group, right? So the idea is the variation across group, okay, will be way larger than variation within group if the null is wrong, right? If the mean are not the same, across group will be, the difference will be large, much larger than the variation within group. So that's ANOVA means. Is that clear? So that is the ANOVA. Okay. So, and now I give you 3 important formulas, then should be fine. Okay. So before I do that, this is how you do SST. But I think you can check it easily, right? Just to illustrate what they are. As I said, I don't expect you to reproduce this in the exam, but you probably want to know how to calculate that. Okay, I'm not expecting you to reproduce in the exam, but you know how to get those. Okay, because nowadays calculator do it for you, right? So you just need to understand what it is, right? So not to expect you to run that. Same as SSG and SSW. I'm not going to do that. Okay, but this is trying to show you that is the way the same. They add up together. Okay. So now we come to the slide we care is how to calculate. Okay. So the MST, right? It's just SST over N. This is come up with the good estimate for sigma, right? If the null is true, this is how we estimate, right? Now we're done with all the estimation of the model, right? If this a model we have all the estimation of mu, all the estimation of sigma. So that's done, right? So with all the estimation. But now, of course, we are not interested in estimation. We're interested in whether mu are the same or not. Okay? We focus on these 2 numbers, which is MSG and MSW, right? And as we said, if null is not true, MS3 will be much larger than MSW, right? So if null is correct, H null is correct, they are the same, right? So let's see how we do this. The only tricky thing is what to divide in the denominator. Okay? What to divide denominator. Okay? And the denominator here is C minus 1. You may ask why. Because how many group mean do we have? C of group mean, right? Suppose you have 3 groups, only 3 group means. So that's why E minus 1 because it's sample. Okay? So that's why C minus 1. Because we're talking about how many group variation, right? Only a C group. Okay? So that's why C minus 1. And you ask why M minus C here. Okay? The idea is very simple. In the MST, you estimate 1 mean. So you take away 1 from that. In here, you have C of group mean, so you minus C. Okay? And that is why. Okay? Of course, the underlying, the very complicated math here, we don't want to elaborate, but that is what the textbook called degree of freedom. Okay? Usually you will see in undergraduate text, they will say, okay, because you estimate C of the sample mean, so that's why you subtract C, right? And that explains why I subtract 1. But I'm not going to explain why this is the case, okay? It requires way much more math we need, okay? Now, once you accept this, this is the last slide we have, okay? And this is the calculation. I'm not going to do this part, but this is the last slide we need, probably up to this slide and 1 more. So this is the last slide we are talking is we do F-test, right? The F-test is basically compare the variance come from the group over within group, right? And as we argue, if null is true, they're the same. If null is not true, this is way larger than this guy, right? Because across group will be much larger than the within group, okay? So that's why it's a right tail test, okay? You put all the 5% on the very end, right? So it's unlike what we taught last time, it's just like 5% here, okay? You put all the 5% here, okay, to do it. And to remind you how you check the F table, right? F table have 2 parts. You have to put C minus 1 and M minus C. Okay? So that will be the, okay? So before the break, I want to show you the ultimate slide that will cut off our exam, which is the slide of Excel. Okay? Our exam cover up to this very last slide, slide 80. Okay? So this tell you, I will show you how to do that after the break. It's how to operationalize this in Excel. But I tell you which entry, I tell you this, and then after the break, I will talk about that. Okay? So this data, okay, we have group 1, this data, group 2, and group 3, right? So same as what we see in the slide. Okay? And these are the group average, right? This is X bar 1, right? This is X bar 2, and this is X bar 3 here, right? And this is S1 square, right? S2 square, so on and so forth, right? So, and so the question is, okay, are they different, right? Of course, you can look at the sample mean is 255, right? There's some more different, right? At least 2 is different from 5, right? The question is it sufficient enough to be different, right? Of course, you can look at the variance and try to tell you probably not, but we have to do it, right? Let's actually do it, okay? And this is SS G, right? Between group, right? And this is SSW, right? And this is SST. As you expect, the red plus orange is blue, right? SST is SSW minus plus SSG, right? Okay. And what's this guy? This guy is C minus 1, right? Because how many group you have? -1, right? C is 3, right? Because for 3 group, C is 3. Okay. And what's this guy? This guy is n minus C, right? N is what? N is 12, right? And the last one, which is this guy, n minus 1, right? And you can see that this plus this gives you this one, right? So that is very nicely, then we see those. Now, not complicatedly, right? This is the MSG, right? MSG come from what? It's just SSG divided by C minus 1, right? So this over this gives you 12, right? 24 over 2 is 12, right? Basically, divide equal, right? And divide this equal to that, right? Because this is MSW. Okay. So that's why I said you never calculate that, but I want to understand the formula in this one, right? Because you always go to Excel and click, then you were done. Okay. So it's not something complicated, but I try to make sure that you understand what's going on here. This green is what? F is MSG over MSW. Okay. So this is 12 over 5, 0.11111, right? Then we're almost done, except the last two, right? The last two is not super complicated. Remember, it's a right tail test. Okay? It's a right tail test. So what is this number? This number is simply F this of 2.347A, and you put the degree of freedom, which is 9 and 2 and 9, and then true. Okay? And 1 minus. Why 1 minus? Because it's a right tail test, right? The F only gives you the left one. Okay? It's a right tail test, right? Because why is a right tail, right? Because compare the variance, you only say now it's wrong if the between group is way larger than the within group, right? So it's a right tail, right? The variance is much larger, right? So that's the right tail. Is that clear? And finally, some of you would not do the p-value, you want to do the critical value, right? The critical value will be here. Use this column, right? Calculate how to calculate this guy, right? The critical value will be F this, sorry, F inverse. Okay. The end tail is 5%, so the left-hand side is 0.95. Okay. And you put 2 and 9, then we're done. Okay, so this is number. This number that beyond that we reject, right? If F is beyond that, you reject, but it's not, so we don't reject. So if you don't reject, that means that the three group mean are the same. We hold this hypothesis. If not, then we drop it. Okay. So that is what I want to say. And oh, sorry, one. I think I have to. Is that okay? And I probably go after, but you can also look at this value in F table, which I shortly go over that. Can I erase this screen? So very quickly, is here. How do you get 2, 9, and that one is here? Okay. The table I have here. This is the right tail, 5%, right? So 2 and 9 is here, this number, right? N1 is 2, 9 is here, right? That's how you get this number. Okay, so that's how I got that number from the table. Is that okay? So I guess that's pretty much for the exam. Okay, and up to here. Okay, and I guess you have problem, right? Or questions. So I open the U-Reply. You can tell me what the problem is. I'll do Q&A first before I proceed. Okay, because I think answering question, answering queries more important than proceeding, especially you have exam next week, right? Next Friday. So open U-Reply. If you have any question, ask first. I try to answer them, but that's pretty much the exam up to coverage up to here. I still continue to do things, but just to reduce anxiety. So the cutoff the exam up to here. Okay. So I open U-Reply. Just make sure that you would ask me some question. I can also go over that. So let's have a 15 minutes break. We'll resume at 10:40. Bye. So for a run, you see the next question. If you ask question, you reply or you drag across. Okay, so let's see your reply. See if Q&A, and then we will go back, continue. So let's see. Okay. High, difficult. Yes. Statistics is difficult, as I said, right? It's statistics is not difficult. It's just you are not familiar with that. Okay. It takes time to it's like math, I would say. I would try to use the what we call blind dating or blind marriage. If you're not a genius of math, it's like you just like hook to this and you keep doing it, and then you know what's going on. And actually you can see my goal of this lecture is trying to give you the idea why this formula makes sense. Okay, because everyone can check the formula easily and run the program very quickly, right? Excel, you can just run it and everything is done. The goal of I'm doing is trying to tell you that, okay, actually there's a way to understand the result. And with now the AI, everything, right? Very soon we'll got replaced by AI, right? But probably before that, we can still do something, right? And that's how to understand the probability. So when we'll discuss next Friday we discuss. Wednesday we still talk about ANOVA, but during this class, the second half we will still do Q&A if you want to ask anything. But we will still cover something because I want to cover other topics as well. What's F statistics? F statistics is very simple. Is F is just simply variance of 1 over F variance of 2, right? We want to see if this is large enough, right? Then we will say the variance of 1 is bigger than 2, right? If it's small enough, we will also say the other way around, right? It's F statistics. And in ANOVA, we are sure that the S1 bigger than S2, we would be worried, right? Only we will say the mean are not the same. If the between group is much larger than between group, right? Then we jump up, right? So that is why it's one tail, right? Otherwise, it's two tail in general. I hope I answered the question. If not, then you can continue to ask. Next one, do we have to know all the calculation by hand or just Excel formula? If I put it this way, if I ask you, then without saying Excel formula, you have to calculate by hand. If I say Excel formula, you can use Excel, you will use Excel formula. Okay? And if you're desperate, okay, you don't know how to do it, you can still write down some Excel formula. If correct, we'll still give you partial credit for that. Okay? But in general, I would, unless I say Excel formula, you should calculate the whole thing. Okay? I hope I answered the question. I hope it's clear. Test day still have lecture. Oh, test day just go over the exam Q&A. So no new stuff. Okay, just go over. I mean, it's optional. You don't have to attend the last one, right? If you want to go to library and study, that's fine. I don't want to. F test. F test again. Okay. F test is like this. As I said, for F test, actually starting from the 2 sample, I expect you only how to know how to use Excel, right? So that would be the thing. But the F test is like this. Okay. The idea is testing whether the variance is the same, okay, or different. Okay. Of course, you can do the one tail. It's the same thing here, right? The idea is very simple, just dividing the sample variance, right? If too large, right, or too small, you reject, right? If too large, then the variance, because this is capturing sigma 1, this is capturing sigma 2. That's the idea. The only thing is you have to be careful what to check. You have to check N1 minus 1, N2 minus 1. Okay? And some of you actually ask, okay, suppose this, in the example, we have 49, 39, right? Then how do you check this guy in the F table? It doesn't appear in our F table directly, but if you ever have a very big F table, which I don't have here, you will check the column 49, row 39 here. Okay? Because the column tells you the N1, right? So go all the way to 49 and go to 39 row. Okay? And since it's not here, then if I actually ask this question, you just give me the Excel output, right? But of course, I will explicitly tell you, give me Excel. Okay? And I'll ask the TA to double check. If you actually do it by hand, this table is sufficient. Okay? If not, then you can just leave Excel. Okay? So there should not be an issue there. Okay? And of course, for the assignment, I expect you to use Excel, right? To help you to look at the table. So you should be able to do that. I hope I answered the question. what are the Excel formula ANOVA? Oh, I will do it now. After that, okay. Maybe I should do it now. How to use F-test? Oh, F-test is compare variance, right? We just said that. The question is like, I have two samples. I want to compare the variance are the same or not, right? The question would be, I have two stock, right? I want to know how risky they are, right? Risk is measured by variance, right? I want to compare the two. That's the question. Another thing is I have two machines. How precise the machine is determined by the sigma square, the variance. I want to compare, is the two machines are the same or not, right? So this is the question. But probably people ask me ANOVA, how to do it in the Excel. Let's do it. Very simple, ANOVA. And you cannot do it in the iPad, but if you Mac, you can do it. So suppose I have data of 4 groups, okay? I just randomly put in data here, okay? Okay. I'll put this Excel spreadsheet on the web so you can have fun on your own. Okay, I just randomly the number. Doesn't really matter. There's some random number here. Okay, I have 4 groups of data. Okay, maybe 4 colleges. Okay, so now what I do is ANOVA. Okay, how to do ANOVA? In Excel, require a special package called add-in. Okay, and I think it's more or less outdated, but anyway, let's do it. How to do that? You have to go to File, and then Options. Okay, and then here you add in. Okay, and the thing we do is called the Analysis 2 pack. Okay, so have to go and then click the Analysis 2 pack. Okay, once you are done in the data, you will see data analysis. Okay, that's even in the Mac you can also do that. Okay, I hope that's okay. If you have a question, let me know. Okay, but of course, I don't expect you to run this in the exam, but you should be able to run that in for your assignment, or if you want to, but you want to do it for a project, right? So how do we just click data analysis? You can see there are many things. Actually, if you see that actually there's many things here, right? You have F-test, you have T-test, all the other things, your regression. But for our class, we just focus on ANOVA single factor. Okay, it's called one-way ANOVA here. Okay, the word top one. Okay, and what you do is very simple. You just input this, and okay, then you're done. So very simple. Okay, the input will be just highlight all the data. Okay, and then the data, the group is by column rather than row. Okay, so you don't do anything. And here there's a label on the first row, so it's yes. You use 5%, right? And next is to tell them where output it. So just put it here. So this is the input, right? You tell them where your input is. Tell them your data is grouped by row or column. Tell them your data is group label, and tell them where your output. Once you do that, click OK. Then you have all the things we want. Okay. So that's how you get the F-test. So how you get the F ANOVA. Okay. I hope that's okay. Right. But of course, as some of you ask me, what would be ANOVA? I would like you to know. The point is this table, right? I expect you how to use this table, right? Or understand how each thing are related, right? That's what I asked in the last year, right? I just put some question mark there, then you can tell me the rest, right? Then I see how you know this or not, right? So that's a question. Okay, I hope that I answer some of your query. How to use F-test. Let me do it once again. So suppose I have data. Let me do the F-test, right? Maybe Excel. Maybe that's fine. I don't need to do it, right? F-test. What should I actually do for the project? Your project, just like remind you, is extend for 10 days already. So 10 days from the original deadline. So your project is just you want to use data to answer a question, right? Maybe use ANOVA, use regression we talked about it today, or you use hypothesis testing, you use the estimation, whatever method will be fine. And I think look at the sample I gave, you know what type of question you're trying to do, right? So I think you can do it in a group or do it by yourself. And number of pages is proportional to the group size. Remember, what I give you is upper limit, not the lower limit, okay? So if you're a large group, you don't need to utilize all the page limit, okay? And it's a business report, right? So expect your report to be concise, right? It's not to pack as many as you want, right? Is to make sure that suppose I'm a client or a boss, I read it, I know what you're doing. And I'm convinced by your finding, that's it. Okay? You don't need to show me all your stuff. Okay? You have done. You don't need to show me, okay, you do this, doesn't work, you do that, doesn't work. Show me what it works. Right? Show me your question, show me your answer. So we're business oriented. Okay? And make sure that today is Friday. So yeah, today is sunny. That is a little bit surprise. North Point. Yeah. I haven't talked about this today, but I will. I haven't talked about regression today. Yeah. So some of you think it's, I don't know, it's too fast or too slow. I think overall it's okay. Okay, that's fun. Will the exam be very hard? The exam, according to the TA, is easier than last year. Okay. And I think it's also easier. You have less question, and I think it's easier. This is cool. And yeah. But as I said, if you know how to do your assignment, you should have no problem for doing your finals. It's not something complicated, I would say. Okay. Any more question? I'll try to see question 1 again. Is there any more question? Okay. So the remaining time, I want to very briefly talk about two-way ANOVA and talk about regression. Okay. I will not go into detail or talk about two-way ANOVA. I just tell you what it is, because you can easily run the Excel. There's nothing deep here. Okay. For two-way ANOVA, it's very simple. The idea is each observation, not just by one grouping, but more than one group. Say, customer can be classified by sex, gender, or age group, right? And you want to see if different grouping would make a difference, right? So you can easily imagine that I do one-way ANOVA twice, right? I just see ANOVA on gender or t-test on gender, right? And I do ANOVA on age group. I'm done. Yes, you're done. You can do that, right? But you do one-way ANOVA, you can answer a question. Is is it possible that only the young female want to pay more, right? The t-test can only show you whether man or woman different, right? And ANOVA can only show whether age group are different, okay? But you cannot show you that might be in particular, young woman pay more and old men pay more than the rest, right? Then you can't do that. But in ANOVA, in 2 ANOVA, you can do that, okay? And at the end of the day, okay, you will be looking at F table like this. Luckily, I'm not asking this year, okay? 2 years ago, I asked this question. Look at this table, okay? But that is not too much different, okay? At the end of the day, look at the p-value. You'll be look at the 3 different tags, okay? And you'll be looking at, say, the data you have will be look like this. The data you have in 2-way ANOVA, data is like this, okay? A will be grouping, say, by age, right? And B may be, say, location, right? B or birth, where they birth, right? A is age, B is birth, say, for example, okay? And if you run ANOVA, okay, this is looking at the columns, looking at whether columns are different, right? They are different by age group. And the sample one is looking at whether the location, the B's, are different. And the last one talking about whether there's some particular feature that, say, young woman or old man will be different. Some combination of those. So we just do this test, okay? And I don't want to cover too much on the ANOVA of 2-way. It's because what is done here is very restrictive. And when you actually do regression, which you will do if you learn further, is 2021, okay? When you do regression, it will include this as a special case, okay? So that means that you would not do this, okay? So that's why I think it's okay to skip, because when actually you do it, you learn the regression will include this thing, and much more general. So this is very restrictive setup. That means that I would probably not use again anyway, right? So since no one uses it, then why I bother, right? I mean, if you actually use it, you will not put in practice usually. You just run the regression, multiple regression, which we don't cover, but if you ever use it, you will use more advanced tools, which will be, this become obsolete. And you ask why we still talk about that, I don't know. It's in the syllabus, I just want to say a little bit, okay? So rather, I want to give the last 10 minutes, give you the idea of regression, which some of you may be thinking about using it in your report. But don't worry, it's very simple. We will like ANOVA teach you how to read the Excel output, mainly. And Excel is the thing that we need, right? And at the end of the day, what I want to do for this class is to tell you how to look at this table, okay? And this is, you can see ANOVA here, but anyway, but that will be the main goal of this set of slide, 80 pages, okay? But I will do this on this class and next class, okay? But don't worry, the idea is super simple, okay? Regression, okay? The idea is very general, which try to study relationship, okay? And some of you, as your undergrad, you will care about whether you want to do a master or MBA upon your graduate, right? The question would be, hey, is it going to make more money? Is it worth it to do an MBA? Is it worth it to do a master, right? Because master is rather expensive, right? You spend 1 year in school, suffering or enjoying exam, right? So does it work? You want to see if education lead to higher income, right? And what do you know? What do we know is look like this. You look at number of year in school, okay? And income, usually your data is like this. That's what you observe in data usually. Okay. Why? This is primary school. This is secondary school. This is college. This is master. This is Ph.D. Okay. And look like this data. Okay. And probably ask why it's increasing up to the bond master. And you go down here. Okay. An example why I go down here, look at me, right? I do the Ph.D. right? But I'm poor, so that is what it is, right? And but you see it's a positively related, right? And if you ask us our covariance or covariance coefficient is positive, right? So what regression is doing is very simple. I want to find a model to condense or consolidate this knowledge. Is in our class, we focus on one thing, drawing a line. I want to find a line to represent this data. Okay? I want to find the line represent data. And if you learn from high school, right? This y-intercept, suppose I call it A, and I call this slope B, right? And this line, we can write y equal to A plus bx, right? This is called the slope-intercept form. You remember that, right? A, if you change A, you will parallel shifting up and down the line. If you make B higher, you will flip over. If you go downward, it's downward. B is negative, it's downward sloping, right? So this is what you learn in high school. If you forget, doesn't really matter. You just know what I said, then done. Okay. I'm not asking you to do crazy coordinate geometry, right? But that is a line, right? So basically, is I want to find A and B such the line best fit the data, right? So here comes a new thing, and actually that's what you learned from the 2021 for the whole semester, is to find how to fit the line in every scenario, right? And here I focus on 1y and 1x. In the 2021, you will focus on more than 1x. That means that you're not fitting a line, you're fitting a plane. If x1, x2. If you have x1, x2, x3, x5 up to x10, it's hyperplane. Okay? And probably you would ask, what is the significance of fitting a line here? The significance is I have a lot of data, but I condense it to two numbers, A and B. So that's our knowledge, right? We come from a very complex information and give us two numbers. I'm done, right? And if you are aware of what recent AI been doing, right? AI is doing like this, right? AI is looking at all the data, right? And condense it to parameter, right? And then probably you know what's different between the ChatGPT 3.5 and 4.5, right? It's number parameter, right? It's whether you have a several billion or several trillion parameter, and parameters like this, right? Of course, the model is very complicated, right? And probably some of you, if you are aware of what is the machine learning or big data analytics, right? Basically, everything is start from regression, different type of regression, right? So regression is, in some sense, is like how to combine the data into a model, right? So that's why we end with regression, and I want to still talk about regression. Although regression doesn't cover it this year, but I think regression is very useful tools if you ever use it. And Many people actually do regression for living, right? As economists, right? Or people who do analysis, basically do regression, right? Of course, there are many types of regression. There's a line, you can fit different things to there, but the main idea is to condense the data into something much more simple. We know how to handle, right? Because once we forget the data, it's all the line matter, right? So only thing we learn how to update or figure out what A and B is, right? And A and B will be the thing we know, right? We make our decision based on A and B, right? That's what happened for supercomputer in the observatory, right? They predict how the typhoon is going to hit Hong Kong or not, right? Whether we have a red rainstorm or black rainstorm, so on and so forth. Okay. Okay. So let's go back before we end. This is a line. So the question is, I want to fit the line, or I want to find the best fit line, but what's the best? Okay, what's the best? The best with the given criteria. Okay, the criteria is very simple. It's like this. I look at the distance from the point vertical to the line. Okay, why vertical distance? Because I want to use x to relate y. Okay, so y is the thing that we want to explain or we want to know, and x is helping us to know y. So the vertical is the thing that we think is an error, we think it's not so accurate, so we want to minimize this inaccuracy. Okay, so let's repeat, because we call y is our thing we want to explain. That's why I call it the explained variable in economics, and x is called explanatory variable, okay? Or sometimes x is called independent variable, and y is called dependent variable. These are all in the slides already, in the black one, so you can read if you want to, it's there. But we want to minimize the distance, okay? And for the math, like the variance, we want to minimize the vertical distance by square, so then we don't need to worry about positive, negative, right? So, so this is the idea. Okay, let's look at this graph. Okay, this line I will call head. Okay, is our estimation, and the data point here, suppose data point C, is called, right, xi. This is yi. Okay, and this guy, right, will be xi yi hat, right? Y hat is what? Is A plus bxi. Okay, and we call this distance di. Okay, what I do is I want to figure out what is A and B to minimize all the distance. Okay, suppose I ended up on. Okay, I want to make this smallest by moving up and down, changing A, rotating, changing B, okay, to make the sum of the square distance minimized. Oh, that's why this is what we call the least square estimate. So least square. Okay. So that's called the least square method. Okay. And okay, so this method, and next class we will tell you more stuff and tell you the Excel output. Okay, and that will be what is sufficient for our purpose. And I will see you next Wednesday. I will stay around to answer any question you might have.